Hello and welcome to another one of these AD videos. Today we'll be looking at a geometric distribution beginner example, as the name of the video implies. As the question states, the probability of winning a raffle is 0.2. And we're asked, what is the probability that you have to buy 6 tickets before you win one? And then the next question is, what is the average number of tickets that should be winners in this raffle? And what is the standard deviation?
So again, the big picture is always, we must identify the distribution. So what are we dealing with? So we're looking for the number of repeated Bernoulli attempts until the first success is achieved. That is a geometric distribution. Number of k trials until success.
The formula for the probability mass function for a geometric distribution for x equals k, probability of x equal k is p. The probability of hitting that first success, in this case, winning the prize, or a prize. And q is the complement of p, which is just 1 minus p. Anytime you hear the word complement, you should think 1 minus probability given. K, again, is the number of trials until we get that first success, minus 1 in the exponent. And then for the mean, we have just 1 over the initial probability that's given for a geometric distribution. And for the variance, it's going to be q, which is 1 minus p over p squared. All right?
So with that in mind, let's see what's going on when we start plugging and chugging into the PMF. Let's answer the first question. What is the probability you have to buy 6 tickets before you win? So here we have plugged into this probability mass function. It's a mass function because it's discrete. Whenever you're dealing with continuous functions, this will become a PDF, probability density function, because it's a continuous curve. Here we have 0.2, which is the probability of winning, times probability of not winning, raised to the 6 minus 1. So this is kind of like a binomial formula where we have PQ raised to the, so the P is raised to the 1 success, right, first success, and then the probability of not succeeding raised to the rest of them. All right. So when you plug into this formula and simplify that, you're going to get this. This will be the probability associated with having to buy 6 tickets before you get your first victory. Now, if I'm looking for the mean, I need to do 1 over that 0.2 that I initially had, probability. And when I simplify that, I get that I should have an average of 5 winning raffle tickets in this raffle based on this probability. Now, if I want the variance, that's just q over p squared, where q is just 1 minus p, the complement of p. And when I plug into that, I'm going to get a 0.8 over 0.02 squared and 0.8 over 0.04, which is 0.2 squared, will give me 20. So that's the variance, and if I want the standard deviation, I just square root the 20 to get the variance. All right? So you can see it's not too bad once you know which direction to go to. The distributions and their conditions are very key to understanding this. This is a table you can find on my website, but the general gist is they're repeated Bernoulli trials. We're here at the geometric, the number of identical Bernoulli trials to obtain the first success. But you need to know the parameters for each condition. You need to know the probability mass function for each condition, the mean formulas, the variance formulas, and what their range is. All right. This table can be found on 24hourtutor.com. Make sure you know this. I would suggest making note cards. On one side, putting the name of the distribution. On the other side, all these other things. All right. But the best way to understand these and know what to do is just to do a bunch of each type of distribution, and it'll become second nature. So as always, practice, practice, practice. Make sure you check out the intermediate and advanced video. And I hope I've clarified things enough for you to at least try a few of these. Okay, you'll see that they're not that bad. Thanks for watching, and have a nice day.